the evolution of Java. So Java Standard Edition, which is helpful in developing console and window applications, and your Enterprise Edition, which is helping you in developing Enterprise Edition. The name itself is called Enterprise Applications, and the Micro Edition is like our Mobile Edition, which is helping you in developing the mobile application. So these are the three different editions of Java. So JSE Standard Edition, JEE Enterprise Edition, and JME is a Micro Edition of Java. And when we are talking about Java, there are many programming languages in the market, right? So for initially there are many languages like Fortran, COBOL, and then C cracked the market. After that, C++ came into the picture. After that, Java came into the picture. But still the Java is remaining in the market, even though many languages were in the market, right? What could be the reason? Because we know the reason is like the two main reasons is you're saying Java is portable and Java is secure. These are the two main reasons why Java is still existing. It's having its charisma in the market because of these two reasons. What do you mean by portable? Just now we have discussed. So when you write a simple C program, and if I compile the C program on a Windows platform and execute that program, I cannot carry that executable code to some Linux environment and then execute that. Why? Because so whenever you're compiling a program, you know that the program will not be directly executed. It needs a language translator like compiler. The C program will be compiled into the target object code, and the object code will be executed on the machine. But the object code varies from platform to platform, so that it cannot be executed on another platform. But when you take the case with Java, so Java is platform independent, means it is generating an intermediate code which is common for all platforms. So how the Java compilation, how the Java was designed and how the compilation was designed is that when you're writing a Java file, so when you employ this Java file to a compiler, so some intermediate code will be generated that is called bytecode, which is common, universal. So means this bytecode can be common for all the platforms. It can be Windows, Linux, Unix, Solaris, anything. The bytecode is the common. But again, the bytecode will be given to Java interpreter. So in order to generate the object target code. So there are 2 points to remember. Java bytecode is platform independent, but the object code is again platform dependent. So bytecode is generated by Java compiler, and the target code is generated by Java interpreter. It's called JRE in Java runtime environment, and Java C is a Java compiler. So whatever the code that is generated by Java compiler is portable, but the JRE is dependent. So if you install JDK on your platform, so the same bytecode that can be used on Linux operating system also, but the JRE varies. The JRE for Windows is different, the JRE for Linux is different, the JRE for Unix is different. Right? So it is having a separate interpreter. Normally a programming language, when you write a program or a COBOL or simple program, so it has to undergo either compilation or interpretation, but Java will undergo both process. Java will be first compiled and then interpreted in order to obtain the target code. So means Java is portable. Why? Because once you compile the code of any other programming language, it cannot be handled into other platforms. But when you compile the Java program, it can be employed to other system, it can be executed on other system. That is why we are calling the Java as a portable programming language. And when it comes to secure, you know, right, nowadays the main source is like the information, and where we are working is internet is vulnerable. It's having many threats. And we are saying that suppose if you are downloading any utility, if you are downloading any file, we don't know that whether the file is infected, whether it is a worm, virus, or a Trojan. Simply, we are thinking that it's a utility, we are just downloading it and installing it. And it is causing harm to our system, right? So we are losing the security. And I'm not saying that Java is very secure, will protect you from all the vulnerabilities that are available. But thing is that When a particular file gets infected, it will allow other files to get infected, right, normally. When you install a file which is having virus, when you download a file which is having virus and save in your system and execute that file, so obviously your entire system will get infected. But there is a case with Java, when you download any Java application which is already infected, so it won't allow other parts of the system to get infected. So that is the beauty of Java. Why? Because every program for its execution should be executed on operating system. We know that. For anything, the operating system is the base. So program should be executed on operating system. But here, Java is creating its own runtime environment, what's called JRE. Means it is having its boundary of execution. So it is no way concerned with the operating system. It is not disturbing other resources to be impacted. So that is the great thing with Java. So Java program is secure in the sense whatever the program you are writing is not. Even though the program was infected, it won't let other programs to get infected. It's the main idea of being what Java is secure. So this is why the Java became very popular, and still we are using Java. And what you can say, I can talk about two different kinds of programming languages, what is structured or procedure-oriented programming languages, and object-oriented programming languages, and one more thing called fourth generation languages, means Perl languages and all. So when we are talking about structured and procedure-oriented programming languages like C or something else, so we mainly concentrate on the procedure only. We mainly concentrate on the procedure. So when an input was given, so we'll be bothering about how to get the output. So we apply some algorithm, we do some process, we'll develop some logic in order to transform this input to the required output. And we are nowhere bothering about what is the status of the input at last. Finally, what we want is that we need the output. So means procedure-oriented languages mainly concentrate on code and logic. Yes, of course, very important thing is logic and code, but procedure-oriented focus is completely on code. So it is nowhere taking care of the data, because data should be hidden properly, data should be provided with some security, data should be provided with some access facility, but that care was not there in procedure-oriented programming language. So we have another approach of solving the problem called object-oriented programming. When you are talking about object-oriented programming, so then many factors come into picture. Like the first thing is that, if I say a very simple thing, procedure-oriented programming will concentrate on code. Object-oriented programming is concentrating upon data. Means it is giving much priority for data as well as code. But in procedure-oriented programming language, it is giving concentration on code only. And think, so there is a language, which is a basic language where we use the reference for learning the ancient languages as well as the modern languages, like it's called C programming. So C is a procedure-oriented language, and of course C is a very powerful language. We can implement many applications, we can develop many applications, as well as systems programming also can be done using C. But C is having some certain limitations. Like C is like vulnerable, because C is having a concept called pointer. So pointer, I think you know what is a pointer, right?
Yes.
Yes, pointer is that it's a reference to the memory where some data will be stored into that memory, right? Means you are accessing directly the memory using a C programming language. We are not bothering about what is the code and all. When there is a concept called pointer, means there is a facility that I can access into the memory. So when you're going to access into the memory, there is no meaning in like having a data variable name or something, because I can access the memory, I can exploit the data from the memory itself. And we are not bothering about that. And in C, when I'm writing some functions, so normally any programming language, you'll be writing some modularity, right? You'll be writing the main program and you'll be writing some subprograms. When you're writing C subprograms, so-called functions in C, so functions are out of main program. So first you'll be coding the main program enclosed, and you will be coding the functions. Like this, function 1, function 2 means outside the main program, whatever you write will be considered as global section. Means it's outside, it's public. So whatever the data that was declared outside, whatever the code that was defined outside will be treated as public, so that anybody can access, any program can access, any file, any function can access. So there is no control over the accessibility of the code and data which was declared outside the main program. And this is a serious concern of security. And it violates the consistency of data, because one function will update the data, at the same time the same data will be updated by another function. So this causes inconsistency and security issue also. That is also major concern in C programming. So keeping this in mind, so they have made some changes and they developed a new language called Java. Of course, in between C and Java, there is one more object-oriented programming language you might have heard called C++. Of course. So Java. So Java, simply say it's an object-oriented programming. Java, it's an object-oriented programming. So what do you mean by object-oriented programming? So what is an object? It's like, object is simply a real-time entity. If I take, so myself is an object, you are an object, the computer is an object. Whatever the thing, whatever the element you notice in the real world is an object, right? Object is having two things. Any object is having two things. One is that object properties, and second one is object behavior. So called, how I can accumulate that two words into programming is like object property, I can say data, and object behavior, I can say code. So what are the attributes of that particular object and what are the functions of that particular object? If I say student will be having some properties and student is having some behavior, like that. So means object means any real world entity which is having its own behavior. So what we're going to do is that we're going to model the real world into a software application. So what we need to do is that we need to identify what are the properties of that particular object and what are the behaviors of that particular object. So the object properties will be vocabulated into like the data type, variables and all. And the behaviors you're writing as a functions, so that you can represent a particular real-time entity as a software entity. So Java is helping you. So that is what object-oriented programming. Object-oriented programming help you in representing a real-world entity in the form of a software. Let us say, so there is a freedom in naming the data structure. There is a freedom in naming a function, but provided with some security, access control and all. So when you can call a particular programming language as object-oriented programming language, so it has to satisfy certain principles. So-called object-oriented principles. So this is where we'll start with Java. The first principle is abstraction. And the second principle is abstraction. The second principle is encapsulation. And third principle is polymorphism. And the fourth principle. So these are the basic principles that should be avoided by a programming language to be called as an object-oriented programming language. But thing is that what you say abstraction is available anywhere. Abstraction is available anywhere. But in COBOL also what we do is that we use some functions directly. Suppose when you want to, like, you're writing like mul, means when you're writing mul, automatically the multiplication operation takes place. But what is there defined in the multiplication mul pseudocode or mul mnemonic, we don't know that. We don't know. We just know how to use mul. That's it. you are using like move. So when you are using a move instruction, thing is that it is transferring data from one particular variable to another particular variable. But what is happening inside, we don't know that. Means abstraction is like it's a selective ignorance. So to be explained, abstraction is that so without going much into the details, we should know only the use case. Right? So user will be very transparent of what is happening inside. So the programming language should exhibit that kind of transparency. So but almost all programming languages will exhibit the same kind of transparency. I cannot say that abstraction is a special feature of object-oriented programming language. All the high-level programming languages are having the abstraction thing. It's not going much into detail. Suppose if I want to find out square root of a given number, what I need to do is that I need to simply use sqrt function. I don't write the code how the square root will be found out using a mathematical operation at all. Because sqrt function is already available. Suppose somebody asks me to reverse a particular string, I use directly a function called reverse. And I'm not going to apply some logic so that I take a string and reverse it and display it. No. Because reverse function is already existing. Means abstraction is that we know how to use, we know how to acquire that particular functionality. But how it was implemented, we are unaware of. That is what the control. So that is how the transparency can be maintained. And what I mean by encapsulation is that, so this is abstraction, what it is doing is that it is reducing the burden on the user. It is making a complex thing into a simple system by making transparency for the user or the programmer and all. So when you're talking about encapsulation, so encapsulation is something which some feature which is concentrating upon the security. As I said, so when the public data was there, when a public function was there, so it is vulnerable. So any other function can access that particular data. But Java will not allow any public declaration. Whatever the code or whatever the data, whatever a single statement you are writing as part of your program should be enclosed within a structure called class. So everything will be belonging to a particular entity called class. So when you are creating, when you are defining, when you are declaring some data or a method or a function or a piece of code, that should be enclosed in a one particular class or multiple classes. It's a different story. So when you are enclosing into that particular entity, so that particular object or data or method is sole property of that entity. So no other entity is allowed to access that. That means you are providing high data security in Java with encapsulation. Encapsulation means like the togetherness of the code and data. Suppose what if you take an object, I said object is having some property, object is having some behavior. So the property and behavior together as a package is called encapsulation. So all the properties can be accessed by those behaviors only. So no other object property can be accessed, or no other object behavior can access our property. So that kind of security will be given by the mechanism called encapsulation. So encapsulation deals with the data security in Java. And what I mean by polymorphism is that polymorphism is again reducing the complexity. Suppose you are developing an application, like suppose I am developing an application like CAD something.
So there are many structures when I am going to engineer a particular automobile engine, or I am going to design a building plan. I need to use some software kind of thing. There are many like geometrical shapes and all. I need to find out the area and all these things. I can directly apply the function. But thing is that, so there are many objects. If I want to write area of a square is one function name, area of a rectangle is one function name, area of a triangle, area of a circle. Like means the functionality is area, but the object is different, right? Area of a square is different, area of a triangle is different. But I am writing the function name multiple times, right? I don't want to do that. I want to remember only one function called area. Depends upon the input what I have given. The function should be able to resolve at runtime to find out the area of a particular object. That means polymorphism means one function exhibiting multiple jobs, like existing in many forms is called polymorphism. Means user, so it is reducing the instruction set so that I cannot remember multiple functions. So I can remember only certain functions. So like if I remember area, of course I can give the parameters. If I want area of a rectangle, I'll give length and breadth. If I want area of a triangle, I'll give base and height. If I want area of a square, I'll give only the side. If I want area of a circle, I will give only the radius of the circle. Means I remember only the function name area, but the parameters can be changed so that I can exhibit the polymorph. Means the same area function is exhibiting multiple functional. This is what polymorphism is. Means, of course, we'll go into the details when we are discussing that. And finally, the thing is that
inheritance. So inheritance I link up with encapsulation and then discuss. What we said is encapsulation is that every data method will be enclosed in a particular secure entity called class together, let's say, so that class is providing some security. So without permission of that particular class, you are not allowed to access any element, any object, any data, any function outside that particular class, right? So in order to access, so means inheritance is like literal meaning. So we can use the property of our ancestor. In the same meaning, inheritance is that when the same code, when the same functionality is to be implemented in our further classes, next class, why to again redo that one? So an inheritance is enabling the feature called reusability. In order to not to duplicate the code, so what it is doing is that you are giving certain access permission so that my data can be used in your class, my class function can be used in your class, so that inheritance can be done. So inheritance is that reusability, it is supporting the reusability. So these are the four basic principles. So any programming language to be called as object-oriented programming language should obey these four principles. Based upon that, so we are going to say whether this programming language is object-oriented or not object-oriented. So how the Core Java part discussion plan will be like. I will give just a rough outline of what we are going to discuss in Core Java part. So the basic class and object, because Java starts with an entity called class and object, and we'll discuss all the data types, how to use those data types and all, and we will discuss arrays and strings in Java. We will discuss all the control structures. Control structures means conditions and loops in Java. And after that, we'll be discussing all four object-oriented principles of Java with their implementations. And after that, we are going to discuss how the file system in Java works. And we are going to discuss how the exception handling in Java can be done. And we are going to discuss how the multi-threading program can be implemented. And we are going to discuss packages and interfaces concept. And we are going to discuss applet programming. And we are going to discuss GUI programming and event handling. So these are the things, it is not a detailed plan of that. So these are the things which comes under Core Java we are going to discuss. So the very first basic introduction to Java, how to write a simple Java hello world program, how to compile it, how to execute it. So what are the different types that are supported by Java, and how to use those data, and how to create a function, how to access that function, and what kinds of functions are available, what are the special kinds of functions, what are the arrays, what are the strings, and what are the control structures in Java, and how these object-oriented principles can be implemented, how the Java file system will work, and how will you handle exceptions in Java, and how you can create a multi-threaded programming in Java, and how to create packages, and how to use interfaces, and how to develop applets, client-side web applications, and how to develop complete GUI window application, how to create event handling on that. So this part we consider as Core Java. If you have any concerns, please let me know.
No, I'm good. Thanks. Okay. Thank you so much.
Okay, thank you.